Why is the Dyson Ball project just a fantasy game? Humanity is at least one whole level of literacy short. Many people have played the sci-fi construction game Dyson Ball Project. In places like the pastoral world, we build interstellar pipelines from scratch, easily stacking massive energy sources that enclose stars, as if controlling the stellar energy and advancing to cosmic secondary civilization. It's something within reach. But almost all players are misled by the game's simplified design. In the current universe, Dyson Spheres have never been simple infrastructure projects. It is a stellar-level super engineering project that crushes the existing human technology system, possessing all the technology we currently possess. None of these are even a fraction of what can be sustained in this project. Behind them lie 7 major technical deadlocks that overturn perceptions. Many people believe that the hardest part of building a Dyson ball is funding and speed. The scientific community has long proven that the cool, perfectly rigid Dyson shells in games fundamentally cannot exist under the current physical rules. The closed stars we see in games look perfectly arranged and perfectly regular, and can be placed in the real universe. No mechanical structure can maintain its stability. The gravity of stars is everywhere. If even a tiny displacement deviation appears on the outside, the entire giant structure can be instantly pulled apart, crashed, or collapsed by the star's gravity. There was no room for remedy. The ultimate source of human imagination is the gigantic being sentenced to death by the fundamental laws of physics first. Since Dyson shell alone is not feasible, can we easily implement the easier-to-use Dyson cloud? The answer remains no. Do you know how much material volume Dyson cloud actually requires for building infrastructure today? In the game, galaxies are extremely compressed and astronomical units are drastically reduced, leading us to mistakenly believe that the resources needed for construction are minimal. But in the real universe, just Dyson cloud, which covers 10% of Taeyong's surface area, requires tens of billions of tons of building materials. These materials require us to disassemble the entire Mercury to barely assemble them. Meanwhile, the current space energy of the human species remains only at the sampling phase of small stars. Not to mention dismantling planets, even the routine large-scale mining in the sky, we haven't had any advanced technology. This raises the second question of disrupting perception. Do we really have enough capacity to launch this cosmic project? Many people believe that Dyson balls are meant to obtain energy sources, so naturally, they foresee and then benefit. But in reality, the total energy consumed in the early stages of building Dyson Cloud is over 1,000,000 times the current global energy consumption. The fossil fuels, general solar energy, and wind energy we currently rely on are insignificant compared to stellar-scale projects. The only entry and exit is 100% mature controlled nuclear fusion technology. But even the world's top labs today have only achieved a brief increase in energy. There is still a world of difference from commercialization, standardization, and the supply of massive energy sources. Without sufficient energy constraints, all Dyson engineering concepts were like towers in the air. After discussing resources and energy sources, the core material bottleneck is the ultimate challenge of shattering everyone's illusions. Can you believe it? The strongest technology known to humanity is naturally indistinguishable from paper, as well as human materials, including graphene and carbon nanotubes. In Dyson's process, it is no different from a sheet of paper. It can withstand stellar high temperatures, cosmic rays, micrometeorite impacts, and simultaneously maintain ultra-light and ultra-high strength. The strength parameters required for special materials are 9 orders of magnitude higher than that of current top-grade materials. What kind of concept is this? It's like asking an ant to carry the entire galaxy. It's a complete dimensional gap. More critically, this material still needs to possess self-repair and anti-aging capabilities. In the extreme cosmic environment of true air, ultra-high temperature and ultra-low temperature, it has operated steadily for millions of years, a domain that previous material science could not fully explore. Even if we manage to overcome material and resource challenges, the track control of dozens of Dyson collection components remains an unsolvable deadlock. All equipment in the game is automatic, never collisions, and operates steadily throughout, with no human intervention. According to current reality, countless scattered energy harvesting components are distributed within an orbital range of hundreds of millions of kilometers. It constantly faces the effects of solar hotspots, sunspots, and planetary gravitational disturbances. Even more challenging is the deadly delay in interstellar communication. For a distance measured in one day's temperature, one-way signal transmission takes a full 8 minutes. An 8-minute time difference means we cannot operate the equipment in real time. Once the assembly experiences track deviation, equipment failures, or ground indications that delay the entire process, it will ultimately trigger a chain collision. This completely paralyzes the entire Dyson cloud system. When faced with the difficulty of impossible operational control, can super-level AI self-control solve all these problems? This is yet another common misconception among the public. Artificial intelligence at this stage can only achieve precise calculations within fixed determinate calculation, and fundamentally lacks the autonomous decision-making and prediction capabilities of space-scale complex systems. Future Dyson systems will require a decentralized distributed AI network. This enables every small device to possess independent sensing, autonomous error correction, and mutual repair capabilities. It can provide advanced prediction of stellar activity, avoid orbital risks, and independently complete replacement of existing faults. This kind of super-level intelligence, far surpassing the development limits of current AI, is an intellectual technical barrier that will be difficult to overcome for hundreds of years. What is even farther and harder to break through is the time and cooperation bottleneck in the civil dimension, which we have practiced for decades, measuring space engineering over a century of time. But the real Dyson cloud construction cycle can take at least several 100,000 years, or even 1,000,000 years. The complete history of humanity has not exceeded 5,000 years, and we have never had a system of engineering inheritance spanning generations or tens of thousands of years. The technology, knowledge, and resources of a generation are difficult to sustain for decades or even centuries. Once turmoil, technical gaps, and resource disputes emerge, this star-level project will be completely over. More importantly, deconstructing the star and remodeling the Taeyong system space involves the entire civilized survival ethics and resource allocation. The current situation of humanity, it fundamentally cannot support an interstellar civilization cooperative system. At this point, many people might think the Dyson Sphere is an unrealistic illusion, but the scientific community has long proposed a more realistic alternative to reality. Compared to Bush, the rigid Dyson shell that physics cannot solve, Dyson rings, and Dyson clouds are currently the only theoretically feasible directions. Especially since the low-density Dyson cloud does not need to dismantle giant planets or break through extreme material technology, it can be progressively built, and iteratively upgraded. This is the only feasible path for humans to reach second-class stars, and in the game, it pursues the ultimate perfection in a fully enclosed structure to create a real universe exploration. It has always been a process of gradual progress and breakthroughs. Today, we seem extremely far from the Dyson Sphere, and every technical bottleneck has trapped humanity for hundreds of years. However, the development of human science and technology has always been about breaking through established understandings. 100 years ago, humans could not have landed on the moon or explored the vast sky. Decades ago, we couldn't imagine the universality of artificial intelligence or quantum technology. Controlled nuclear fusion, space mining, new special materials, and the use of artificial intelligence. These technologies, which now seem distant, are gradually moving from science fiction to reality. As humanity gradually breaks through layers of barriers in materials, energy, intelligence, and interstellar engineering, slowly preparing to rebuild the Taeyong system and harness the power of stellar energy, we truly understand the key. It has never been just unlimited clean energy. In the vast universe, mastering stellar energy has always been just the basic threshold for a second-level civilization. What truly awaits humanity and the ultimate path of evolution for human civilization has only just begun its most humble beginning.